Welcome everybody to day 2 of the 2420. Today we're going to cover the following points. Let's get this up on your screen here. I need to set this to display settings on my end to duplicate. The record will match what you see on the screen. Excellent. We will be reviewing the concept of stack versus heap. We covered that briefly last time. Also, again, dynamic allocation and deallocation. In my opinion, this second item seems to be the hardest concept, the hardest single concept to pick up. We could do it over and over and over again, and people try to, it's very easy to merge concepts. It really involves 2 or 3 concepts crammed into one, and students want to think of it as one concept. We have now multiple types of pointers: raw pointers, unique pointers, shared pointers. We'll overview these. If past history is any indication, you guys will learn about raw pointers and then hate them and not want to see them again. I find this is a useful way for beginning programmers to understand pointers, is to treat pointers and arrays effectively like they're the same thing. Briefly understand what pointer arithmetic is. We don't really do much, if any, pointer arithmetic is in this class, but it does help you to understand more of what's happening. Much of this class is, if you can understand the concept, you can then better program and debug the concept. Knowing why makes solving problems so much easier. Templates are quick and easy to understand. We'll cover those today. And we want to start implementing a container which internally holds an array. This will be a theme of a lot of this class. Data structures are quite frequently data containers. You can use them to hold lots of other data. If you were in the Java class, you used ArrayList probably as a container. Did any of you use vectors in your 1410 class to hold data? Arrays are, of course, just a native data structure, a native container. I will discard my annotations. So we'll come back to this slide at the end. Let me make sure my online students are here. Online students, you can still see and hear me. Is that correct? All right. Just as another reminder, if for any reason a student asks a question, I will try to remember to repeat it. But if I don't, someone can please bug me and just say, what was that question again? That way it gets in the recording, and also so the online students can hear it. All right, let's just start with questions. Do you guys have any questions from last time? Anything that was brought up? Any class policy stuff? Yes?
Oh, policy. Just when you were bringing up like the using thing, like normally I was used to just being one, like using namespace SC, but you have like 3 different ones.
Yes.
I just want to understand that.
So this is the old style. A lot of people still do the old style. Okay. I'm not a fan of this because it means that everything checks. Let's back up even further. Jason, I'll get to your question, but I'm handling, was it Mason?
Jake.
Jake. I will handle Jake's question right now. It's Jake?
Yes. Okay,
and there's a Jacob?
Yeah.
Okay. Why we do this, what would happen if none of these were even here? Let's say those were gone. Now what happens? It doesn't compile. Why?
Does it not read your cout statement?
It doesn't know what it doesn't know what cout, cin, and endl are. It's not that it doesn't have access, it just doesn't know what they are. The reason these are here is that when you start getting into very big, complicated programs, the chance that 2 people have the same name for something is great. For example, I just dealt with a Jake and a Jacob here. How do you differentiate between a Jake and a Jacob? One is you can say, oh, make them slightly different. Uppercase, lowercase, Jake, Jacob. But then what's the next one? It's Jacob Smith. Are there other Jacob Smiths in the world? Do you ever get a Jacob Smith's mail by chance? Does it ever happen to you?
No, that one hasn't happened.
I get bradpeterson@gmail.com email almost daily. It gets interesting. I've almost broken up with other people's girlfriends. I've received dinner invites to somebody else's house in Layton. Lots of legal documents. I had some marijuana documents sent to me. It's from the state of California, some laboratory stuff. Like this, it's fun. You should almost get a generic email account just to see what you get. But so how do you differentiate between these things? Much like we have first name and last name, what we do instead is we have namespaces. So cout, endl, cin, and others are all put in the std namespace. Think of std as being the last name, these things being the first name. So if you wanted to give the full name, you would actually say std colon colon, std colon colon, std colon colon. And that gets kind of obnoxious, correct? To do that every single time. You'll see in a lot of big programs, just because of complexity, they will actually write these out just so it's clear which one is which. The lazy way around this is to say using namespace std. What that means is if the compiler can't find something, it will assume and try to see, is it in that namespace? So that puts a little bit more work. Further, it's possible you could have two different libraries that both have the same named thing. So let's say you have a second library using namespace Brad's awesome library. And let's say both of these now have a cout in it, or they both have an endl. Now what happens when I try to use the endl? If they both have an endl, I've got a naming conflict once again. So the way you solve this is instead of just trying to include everything, you manually specify each individual tool you're using. It makes things faster to compile. It also makes things, it avoids conflicts. So that's why we do it. Yes?
If a conflict arises because you include two namespaces that have conflicting symbols, will it fail to compile or default to the first or last?
It'll probably fail to compile, but it's not just that they have to have conflicting stuff. You have to try to use something that's conflicting. Then, so you already have access to all these things by including IOStream, but the mere act of using it then makes it go try to figure out what it is. Other questions so far? All right, where we left off. No, Jason had a question. Should we take notes during your lecture or post? I won't be posting my slides, so feel free to take all the notes you want during the lecture. I don't care. I do record the lecture videos so that you have the chance to go back and look at stuff that you miss. I never enjoyed furiously writing while people were talking. I don't feel like I ever learned that way. I do encourage people to code while I type. It's like the American Idol effect, or if you watch, say, an NBA game, you kind of sit back and say, oh, I could do that. That doesn't look so hard. I could get up there and sing. But what's the reality of actually doing it? Much, much harder. I get the same concept in this class. People say, oh boy, Brad, you make it look so easy. I assumed it would be easy because it flowed so effortlessly for you. But then I tried it and there were bugs galore. What's wrong with me? The best way for you to learn is to actually try typing yourself, even if it means you simply type along. Typing along is much, much better than simply watching along. All right, last time we talked about stack and heap. The idea behind this was you do have a program stack. It's nice and small. It holds all your variables. But what if you need more data? You use the heap. But how do you access the heap?
Dynamic memory allocation.
Through dynamic memory allocation. You can't just get it. You have to use some tool to get there. Common tools are malloc, which we will not touch in this class, new, make shared, and make unique. And all the allocations have their own deallocation to go with it. If you use some kind of an allocation like we're using here, I use new. What does new do? It's a request to who? To the compiler, to C++, to the OS? The operating system. Operating system, will you please do what? Can you set aside some memory? Does it actually need to know? Does it actually set aside a bunch of chars? No, what it does is it looks at the size of what you're requesting times the size of the data type, multiplies those together, and then just sets up a contiguous chunk of memory, and it gives that to you. And what does it return?
The address.
It returns for you simply an address. It doesn't return don't think that it returns an array. It doesn't return objects. It returns an address. It's an address to the leftmost element. And where do you store that address? In a pointer that can hold the address. And you have to make sure your data types match. There's a lot going on in this one line of code here. Some of you have asked, or will probably ask, why did I have 2 spaces here? Did you guys have to do pointers this way? You did pointers this way? A lot of seasoned developers will do it this way. Wait. No. This is the way that you're supposed to do it. This is the way that a lot of people want to do it. Here's the issue. This is the proper way to do it. The highlighted region is the data type. The data type has a space in it. I find that rather confusing. The identifier is that region. I do not like that a data type has a space and the delimiter doesn't have a space. It bugs me. So often I'll do it this way, just to really say, you know what, here's the data type, here's the identifier. You can have as many spaces as you want. If you don't like me, just do that. You can also get away with this, I think. I think you can get away. I don't know, just don't do it. I like this one more because it feels like this is the data type. Char star is the data type. I'm not holding chars, I'm holding a pointer to chars. Jason asked, what's the point of the asterisk? It means I'm holding an address. Nothing more, nothing less. That's all it can store. Yes?
So, when you're working with the addresses inside pointers and things, the way to actually access that is through the _, right?
We'll talk, yeah, we're going to get to that. There's a lot going on here.
I was going to say, I remember that you use both of them in concert. Basically.
Right, so really, C++, like the English language, will reuse syntax. So reuse of the asterisk. You have, of course, multiply. You have something called declaring a pointer data type to hold an address. There's a third. It's called dereference. We haven't shown you the third one yet. Let's go back. What is the size? First, is that screen, can everyone read that? The back row folks, you can read it?
I kind of want it a little bigger. Like, in the back I couldn't read it, so I moved it here, but even then it was still.
Better?
Yeah.
All right. I always like to ask, how big is this data type? For example, a single char. How many bytes or bits does it require? 1 byte, 8 bits. How about an int? How many bytes or bits does an int require? 4. 4 bytes, 32 bits. The strangely named long data type. 64 bits, 8 bytes. How about the float data type for decimal? It's not exactly a decimal, but it approximates decimals. 32 bits, 4 bytes. How about the double? No, it's a double float, so it's 64 bits, 8 bytes. The short integer, the short data type. 2 bytes, 16 ints. All right, the pointer data type. This is a different data type. It has nothing, it points to chars, but it has nothing to do with chars as far as its size is concerned. How big is this data type?
Since it's an address,
it is an address.
it's as large as addresses are on your home machine.
Yes, it's as big as the addresses are on the operating system. Am I running this as a 32-bit application or running it as a 64-bit application? Most of the time I compile it as 32. I got a 64-bit OS. When people hear that, like, wow, 64-bit OS, it must be twice as fast. Because it's more than the 32-bit OS. In reality, you know what it means? Just more addressable space. Your addresses, your pointer addresses, are either 64 bits long or 32 bits long. Why do we need to go to a 64-bit OS? Because 32-bit operating systems can only have 4 gigabytes worth of address space. We have more than 4 gigabytes of RAM now. So 64-bit programs are needed. All right. So this data type, ARR, is literally 32 bits. Mine will be 32 bits. Yours might be 64 bits. Does it have any extra bits to determine where the array ends? Does it tell me? Does ARR know how big the array is? What does it know? Where the first element is. What else does it know? In fact, it doesn't even know where the first element is. It just thinks that's where it is. Because I can be a jerk to it. What did I just do? Change the address by what? 1 slot ahead. Because these are chars, it will only move at 1 byte ahead. If they were an int array, it would move at 4 bytes ahead. Because it moves at 1 slot ahead. Does it know where the 0th element of the array really is now? No, me as the programmer knows, but ARR doesn't. Does it know where the end is? No. Let's not be a jerk. At least today. How do I write data to the 0th element, the very first byte of this array? I can dereference is the basic way of doing it. Dereference and say I want to write something there. How about the value 42? Hold on, we'll get to that. I'm showing you just a little more low-level approach to this. What does that do for me? The first index is, let's take a look. Uh-oh, I got an error. Right access violation. What just happened? ARR was, that's a garbage looking address. Oh, it's down here. Do you see where the error is? Yellow arrow here on line 25, but what happened? I deleted the array. Oh, I did 2 bad things here. I reclaim the array, then I try to write something to the array. Is that a good idea? No. The first thing that you should do is whenever you reclaim memory, you should null out the pointer. The only time you can actually assign a value to a pointer is to assign it the address 0, or the null pointer. This is good. The moment you give up the array, you should immediately say, I don't know where it is. Because otherwise, sometimes it's like a ghostly image. You can try to access data afterwards and work with it. Sometimes it lets you. Sometimes it crashes. It makes debugging a nightmare.
You can use some really weird stuff when it lets you go.
Was it the Heartbleed bug or the flaw that came out where they could ask web servers to just dump out, say, 64 kilobytes of whatever's in RAM at a random spot?
Yeah, that was...
That's kind of scary because you don't really care about encrypting your data in your RAM. So people found credit card numbers that way. So once I delete it, I don't want to use it. I'm going to get rid of those 2 lines of code. That's nasty stuff. All right, let's try again. The first index is, oh, that's, I know what happened. Can anybody explain this? This is an unfortunate coincidence for me. It's a confusing coincidence. That is the ASCII value of 42. Do you remember your ASCII tables? People are looking at me. Some of you, oh yeah, I get it. Other people.
It's a character. You have a character.
Right. ASCII table. Let's pull this up. 42 is the asterisk. The problem with I choose 42 for a reason. Let's go to Google. The answer to life, the universe, and everything.
I didn't know that Google had actually done that.
It's a constant, so I could take the cosine of this, and it will give me I could take the value and multiply it by 2. It's 84. See, it's just a constant.
That's brilliant. I love it.
So the char is kind of a Swiss Army knife data type of C++. It is used in 3 ways. Char is ASCII characters, or it's 8-byte int, or it's go away stuff. Stop. Be proper with my grammar. Or it's a byte data type. It can be any one of those 3. And they're all really interchangeable because at its core, chars hold 8 bits, so it can hold values 0 through 255. So I can assign it a raw value. I could have also assigned it its equivalent ASCII value. 42 just annoyingly is, let's do something else. John Stockton's number is 12. We'll do that. Or let's do Donovan Mitchell's, 45. There we go. 45's ASCII value is a minus. Make sense so far? What if I want to write not to the 0th index, or the 0th item, but I want to write to the next item in line? How do I do that? I could do it this way. There we go, I gave it a new value. I moved the pointer ahead and did it. That's kind of obnoxious. I could do pointer arithmetic on the fly like this. Now what? It works. What if I want to go to index 10? Does that seem needlessly annoying? What's a better way to do it?
Just use the square bracket.
Just use the square brackets. ARR1 is equal to 46. ARR10 is equal to 32. ARR at 0 is 45. These lines of code are exactly the same from the compiler's point of view as those lines of code. What do you like better as a programmer? The first set or the second set? Square brackets are usually the preferred option. There are times, though, that the first way is better, but I like the second way too. Does the compiler know if you're going out of bounds? Could I do this? ARR plus, what was that? Is that 10 million? All right, let's do 10 million. Add on 10 million and do some evil value. The compiler doesn't know. Why?
It's not checking until you have to.
Does the compiler know how big the array is? No. Does the pointer know how big the array? Does the address know how big the array is? So what's going to happen? It will really try it. And then what will happen?
Something unexpected.
Something unexpected. It might work. Sometimes you can write beyond array bounds. And you get away with it because you don't hurt whatever was past that array. Sometimes it crashes. So you have to ask yourself, do I feel lucky? Well, do you, punk? It's not as dramatic as when Dirty Harry does it. So there's no array bounds checking in C++ arrays. Further, like our C++, like in Java, C++ arrays are really objects. They do have bounds checking. But in C++, there is no bounds checking. They're just raw chunks of memory, no header, no footer, nothing special. It is as raw and low level as you get. You are the god of your computer. Good luck. Don't break it. You okay with that idea? Let's go even a little bit further. So could I do this? It's the same exact thing as before, right? Can I move a pointer backwards? Could I say array? Could I say go backwards? Is that legal? Sure, it doesn't know what. It'll try to move it back and say, oh, I'm at this address. I want to go back an address. So could I do this? It doesn't know better. It will try it. Could I do this? Doesn't know better, it will try it. It's the same thing. Do you see what I'm getting at when I say that pointers and arrays are kind of like the same thing? ARR is really just an address. To go to an element of the address, I have to offset it. And the offsetting math is literally just saying, take your address and use pointer arithmetic and go over that many slots. You okay with that? Any questions? Cooper, if I see 42s on the exams, I'll be very happy. It doesn't get you points, but I'm happy. I get students telling me jokes all the time on the exams, and I really love it.
This is great, but you still fail.
That's what I say. I tell them to my wife. It's terrible. At the end of the semester, everybody gets cynical. Then I come across a test. All right, they didn't do anything. This will be an easy grade. I wish more students didn't do their exam. Wait, no, that's the wrong attitude. All right, so we got our array. We can write to elements as much as we want. We can delete the array. We're good to go. Any questions on that so far? Maybe I'll leave that commented in. Hold on. I can highlight a whole chunk of code. I have a hotkey, Control-K, Control-C, which will comment it out. Additionally, I can just click that button and that will comment out a group of code for me. And it also tells you the hotkey to take. Alicia says, can you repeat why you delete array and why you assign null pointer, please? All right, what is delete actually doing? If it were written as a sentence, what does delete do? It reclaims the data to who? The operating system. What would happen if I didn't reclaim the data to the operating system? The operating system doesn't know that I've stopped using it. When does it ever get it back? When you close the program. The operating system at least knows this program is using it, but it doesn't know when you as the programmer manually stopped using it.
Is it your program itself, or is it like Visual Studio when you close Visual Studio?
No, the operating system itself knows every time a program requested memory, the operating system will keep a running list. This program requested addresses at these spots for this size.
When the program closed, I didn't know if you meant like
when the program, yeah, like if I compiled it, I'm not on Visual Studio anymore.
Okay.
Yes, it will. The operating system keeps track of it, but it doesn't know when the program is running when I've stopped using it. So, for example, this is a really bad thing to do. Let's just do while true. ARR is equal to new char 10. Some of you are already cringing. I like that. All right, for those of you who don't get, well, I'll just explain it. If you didn't quite cringe yet, every time you're looping, you're forgetting the old address, obtaining a new address, and you're constantly allocating more 10-byte chunks. You never stop allocating 10-byte chunks because it's an infinite loop. So eventually you run out of memory on your address space. It's not exactly tied to RAM, it's tied to your memory, and your memory might map to, it's usually mapping to RAM, but it might also map to hard drive space if you don't have enough RAM. And it hits a point where it just slows way down, the operating system becomes sluggish. Linux fortunately has a little thing that detects it and kills your program. I haven't seen Windows be as good as that. Yeah, we're not doing that. So the delete, and you have to say square brackets if you use new with square brackets. The delete is saying operating system, I am done with this chunk of memory. Does the operating system go and zero it back out and clean it all up and polish it, ready for vacuum it? Just detaches it. It's like if you go dumpster diving. What are you going to get? When you get the memory, what's in this array when I retrieve it? Is it all zeroed out, ready to go? It's garbage data. Could be good data, it could be fun garbage, could be annoying garbage. And then once if you reclaim it, you still know the address of where you were. And often you can go back there and see what you just left behind. And that causes nasty problems. So a good rule of thumb is the moment you delete, you should immediately null pointer it. because you want to forget the address. It's like if you had a really bad breakup with somebody. Here's your sweater, here's your stuff back. I don't ever want to think about you again. Delete. Get rid. You don't ever have no way to contact them ever again. Yes.
So, if you use the delete operator without square brackets on something that is an array,
it doesn't match.
Oh, okay, so that is illegal.
Yeah, so it's almost as if, let me give you a description of these. I'm going to zoom back in here. It's my big heap. View, let's go back to 100%. Here we are. I got room. Oh, I haven't used malloc forever. Malloc is the C way of asking for data. Allocate, make allocate, and I think is it free? I think is the way you give it back. Might be a dealloc. We have new. New is good for a single item, like a single object, a single int. Delete is its associated cleanup. There is new, assuming you're going to be using square brackets, so you have to use delete with square brackets. There is something coming up called make. We'll do make shared. And this auto cleans. And there's also something called make unique. And this auto cleans. So here are our 5 different types of ways of allocating and getting the data back. Does that answer your question?
Not quite.
Well, it was a good answer. You should.
Sorry, I guess.
No, it's not.
So like you have to use if whatever the object is.
Whatever you did, you have to use its pair to clean it up.
I understand that that is necessary, but in the interest of avoiding future problems, will the compiler stop me if I try to?
Sometimes yes, sometimes no. I've seen people try to do malloc and then delete, or new and then free. Sometimes you get away with it, sometimes you don't. A lot of these things are unspecified behavior. You're better off not doing it.
Yeah, I wasn't.
Don't be brave. No, we don't want any free experimenters here. Follow the rules. Conform. All right. Cooper, null pointer versus 0. Before C++11 standard, you would use null. And null was actually the value 0. It's just defined as 0. Because of some intricacies of template programming, they added null pointer, which usually means 0, but it can mean something more like a true null pointer data type. For the point of this class, assume that null pointer lowercase is the new standard. You should use it and treat it as being 0. But I don't want you saying equals 0 anymore. I want you using the word null pointer.
And that's primarily for semantic clarity.
And also for some really neat template stuff down the road. Templates are ridiculously powerful. They're a language within a language, effectively. We will not touch anywhere near the level of fun stuff you could do with templates, but it helps some template problems that were had beforehand.
So to clarify, if we have a program where something equals 0, you want us to use null pointer.
Correct. Yep. Other questions so far? Is this a good review of things you should have learned in 1410 and either did learn or you forgot? All right. Let's see, what do we want to cover next? I want to make sure I've got the array stuff figured out. Just so you know, if you had... Oh, let's do this one. Let's say you had an actual value, int val equals 42. This is kind of how more people talk about pointers. And I don't like this lesson as much, but if you want to try to relate it back to what you used to, you might have been taught this way, here we go. How do I get the address of that actual val? I have to make a pointer to hold it, and then I have to say get the address of. So whatever you say, it will get the address of that thing. And what do you store an address in? A pointer. Again, don't let pointers scare you. They're simply addresses to some chunk of memory. Nothing more, nothing less. Do not overthink it. I hated pointers, and I vowed to ignore them and try to live without them. And somebody just smacked me and said, no, they're pointers to chunks of memory. That's it. Don't be afraid. So what's interesting here is val an array. No, it's just a single item, correct? But because it's now a pointer, could I start treating it like an array? Not going to stop me. Because does it know it's an array? No, square brackets just means go to the address and offset it by that many. So when I say that pointers and arrays are kind of like the same thing, that's what I'm getting at. If you have a pointer, you can use square bracket indexing. Not necessarily that you should, but you can.
So what that would be like if you were to put a 1 in there, essentially what it would
It'll write 1 past the bounds in memory where it was. And so wherever it was in the stack, it can mess it up. And this is where, have you ever heard of a buffer overflow exploit? This is where in the program stack, I didn't show this, but between each function call, there's really some things such as how to jump back to the previous function and some offsetting stuff. Boy, my pen board doesn't want to work today. Anyways, let's keep going with this. So there's some offsetting stuff here. It is not picking it up. And when you write beyond your array bounds, let's say you were trying to write into F, but you really wanted to write past it, you can actually start writing into these regions. And that causes also, you can say, no, I don't want to jump there. I want you to jump over here. And you can put your own programmable code here. And you can do all sorts of hacky stuff. It's the #1 way that people use to hack. All right, Alyssa says we should take a break and look at memes.
It's just relatable to pointers.
Let's go here. Oh, no, did I just lose everybody? I hope not. Good, we're still here. We're going to redirect. I'm a Java programmer. What does Java programmer mean? It means he's afraid of pointers. No, it doesn't. Pointer syntax. Stop it, Patrick. You're scaring him. I like it.
I just thought it was.
I enjoy it. All right. Online students, I'm going to give you a quick heads up. We're going to... I apologize again. Students who are online are sometimes just saying, I want all the data packed in as efficiently as possible. They get really annoyed if I watch a video or do a joke or talk about the jazz for 30 seconds. I do it because it keeps students in the class awake. And it keeps the class enjoyable. So you enjoy coming to class and you need a little break here or there. Do your best to skip through. You can use the little bar across the bottom of your screen. In YouTube, you have some video. It kind of shows you what the video is going to be when you click on that. Skip ahead, but I will still be having a little fun every now and then. Also, what we need to do is the first of our participation codes. Let me do a new page. I will have 6 digits of participation codes. We got the first one out. Someone give me a digit between 0 through 9. 8 is our first participation code. Boy, I cannot. My pen board has just stopped. If anybody knows how to change the sensitivity, do you see what's happening where, can you hear that? It should be drawn dots. Is it drawn dots? Not often. If you can find out why that is, and you don't want to listen to me, I would appreciate that. All right, our first participation code digit is an 8. You got it? Let's move on. All right, so we've got the idea of pointers. We've done our new, we've done our delete. We did a new array. We're not going to use the regular new as often in this class. We store our results in pointers. We reclaim our data. We've got the address of. Let's do one more thing that's sort of related to this. How do you pass that? Let's do it with a string. Yeah, let's do that. That's a better way. Include string. Using std string. We're going to include string some value here. I'm writing all over my program. You got the include string using std string. I'm making a function for string. Let's make a string, my string. Let's initialize it. Does anybody have a short and cute little saying that you live by? Anything you want this?
Good enough.
What?
Good enough.
It's good enough.
Reach your goals, avoid disappointment.
That's too long. Any others?
Let's talk about what's possible.
Let's talk about what's possible. These are all good. Disappointment.
Wow.
Team if everything. Oh, I know. Does anybody watch The Good Place in this class? It's a good show. They have Team Cockroach. If you haven't watched The Good Place, I would strongly encourage it. You can go back and watch. I think it's even on Netflix now. Do not spoil it. It's one of those shows that it has theorizers going crazy. Every episode will spoil the previous one. It's a lot of fun. We'll do Team Cockroach. No. I asked for the class and I ignored all of you and I took it, my own. What was yours? Something about it possible?
Let's talk about what's possible.
Let's talk about if it's possible, like that?
Yeah.
All right. I want to call this function passing in my string. What happens? Something interesting happens at this point. What is it? First, am I passing in the string directly? No. It gets copied. This is a by value reference. It gets copied. Is that so bad that it gets copied? Who had a longer saying? What was yours again?
Aim low, reach your goals, avoid disappointment.
Aim low, reach your goals, avoid disappointment. Did I spell that correctly? Point. There we are. Let's say for whatever reason your model wasn't just this. Let's say it was multi-line. Let's say it was an entire novel. Took gigabytes in size. It was a whole bunch of stuff. Now is making a copy a bad thing? Why? You're using more space. It's also slower and unnecessary, it seems, to go through and make a full copy of an object. How long will that object live? That copy lives in its scope braces. It lives in that and it dies in that region. So it's kind of weird that we made a copy just for that set and then we let it die. Is there a better way to do this than making a by value or a copy of it? The C way of doing it, not C++ but C, was to say, you know what? Why don't we get sneaky and we will pass the address of it. This is an address. It is, oh, what is the term? I forget it. Requires one dereference. So now instead of passing in my string, I will pass in the address to my string. Do you see that? I take the ampersand. That says, give me the address. This holds the address. And now for me to work with it, I have to dereference it everywhere. Whereas here, I could have just grabbed it in a clean way. There's two problems I feel in this approach. The first one, does anybody see a problem that you don't like about it? What would you say is a problem? Yes?
Wouldn't you want to make a constant, or put a constant in there so you're not accidentally changing?
That could be a third problem. So now you might say, look, this is my important thing. Aim low, reach your goals, avoid disappointment. And this person could say, today is the worst day of your life so far. So they could change your life motto. It's probably not what you wanted when you called that some function. What else? I think it's uglier. Do you want to remember to do ampersand, pointer, dereference every single time? I sure don't. A third one, it's slightly inefficient because you have the address. It has to go out to memory then and find the string, return that, and then it can work with it. So it actually makes a little bit more of an extra hop to memory to do this. Yes?
So I have the hands pulled up so it's easier to see the screen, and a lot of people are saying they lost sound in video.
Uh-oh. Let's do this. Are we back? Share screen. Can you guys hear me? All right. How much did you miss? Brady, re-ask that question. We were going over this again. There are some rules, and I forget what they are, with constant pointers. Is it the address that's constant or the data itself that's constant? And I always forget this. One of the two is constant. In this situation, nothing is constant. Therefore, it's easily modifiable. That's maybe something we don't want. A second problem is that it has ugly syntax. A third problem is that it's a bit slower because it requires a dereference hop. C++11 gives us a cleaner way to get there. What is it? Or C++ gives us a cleaner way. What is it? A by reference. In this situation, we're reusing the ampersand. This does not mean address of anymore. It's a new usage that has nothing to do with address of. What this means is I can use it like I did in my by value approach, but the compiler is smart enough now. The compiler says, oh, you want to pull this data in by reference. Does it make a copy of it anymore? No. Does it need an extra dereference hop? No. It just says, I know where the data is. I'm just going to treat it. I'll compile the code because I know where it's at. So it's cleaner. We don't need the hop. We still have the const problem. People can change it, so how do we fix it? Throw a const in front of it. You will find in my class that I like to make everything const and by reference as the default. To the point that I really wish C++ made that the default, and you had to go out of your way to say, not const, by val. Just be really annoying that if you didn't want to do the const by reference, you had to specify it. No. It's just the reality of C++. You have to say const, you have to say by reference. And I'll be using const a lot in this class. Whereas a student said, hey, if I put 42 on the exams, will that make you happy? Uh-huh. But if you put const everywhere, I'll be even happier. Yes?
So literally the only difference between by value and by reference is just in your actual function itself. The parameters, you're just putting the ampersand.
This one makes a full copy. This one does not make a copy.
As far as syntax.
But the syntax is now nice and clean again.
The only thing that is different is just the ampersand, the one ampersand.
Mm-hmm.
Okay. Both in the function call and in the function parameters itself.
Mm-hmm. So here I don't have to use, it's all clean again. Tage.
If I remember right from my 1410 class, you can't use reference if you're trying to get a variable from another, like another reference page or another header page. You only can use pointers between different.
Yeah, a lot of the old libraries like to have pointers to things. A lot of the newer libraries like to have references. But there's a lot of old libraries out there that still do it by pointer. It's a little bit inefficient. The reference way is better.
Right. I think I'm just being mixed up in my head.
Okay, let me know if you find out what you're. If I'm missing something, you know where you're going. Let me know again. Okay.
Well, I think what it was is that if you make like a separate object file and you import that file, you have to, if you reference anything, you have to use the pointer. You can't use the ampersand.
I'd have to see it in usage.
Okay.
For this class, I'm going to do everything as one file only.
Okay.
I won't do multi-file projects. It's easier for me to debug. Other questions? Just a heads up, there is a new one. C++ 11 gave us a new approach. It is this. This is called a move reference. Where the previous one was a by reference, we'll talk about this more. It holds R values. Even in this step, at some point a copy has to happen elsewhere in the code. This move step is a way that you can avoid all copies throughout the program. Let me see if I can show you. See this? I had to make something and copy it into this. So there was actually a real copy that happened here.
Okay, so you couldn't pass a literal value.
So let's suppose I do it this way now. In the by reference approach, you don't have to know this today. If this is overwhelming, just tune out, start singing a song, watch YouTube videos. But if you want to prepare yourself for what's to come, it should compile. I think it compiles both. I should find out. My function must. Oh, I made them ints, didn't I? Let's make them voids. Void. It does compile. However, this one's still first number one. It makes actually a C string, a char array. Then it copies the char array into this because it has no other choice. The second way, it actually uses the same thing and moves it in, so no copy happens at all. So if you really want to get down to total efficiency and avoiding all copies, you start using this new by movement approach. We won't use it very often, but it does come in handy, and you will see it in use in industry. Yes?
So that by movement function, say that was the only one that you had defined here, and you tried to use...
We're not going to get... There's ways around it. We're not going to get into it yet. Yes, you can. We're not talking about it now. I just want you to know really the 4 ways of passing data into functions. Does that clear it up, or did I just confuse things more? People are looking at me silly. All right, give me some feedback. How many of you, it's solid, it's making sense? Keep going, raise your hands. How many of you feel a little bit hazy? This is a lot to throw at you. All right, how many of you feel totally overwhelmed? Please be honest, because it helps me with my ability to teach. Feel no shame. No one wants to, all right. So some of you who are hazy, would you like, I know a lot of times it takes just sinking in. Is there any part of this that you would like me to go over more?
I just have 2 questions.
Yes.
The first one is, why do you use the const keyword again?
So the const keyword it's good for 2 reasons. Number 1, you know that when you use it, that like let's say it's somebody else's code. It's often not just all your code. It's often you're working with a bunch of libraries, other people's codes. You don't want to pass your stuff into somebody else's function with the thought that maybe they could change it. When it's const, there's a proper guarantee that it can't be changed. The second reason is when things are const, it actually allows the compiler to do optimizations, and sometimes your code executes faster as a result. A third reason is that it's defensive programming. You might make a mistake and might actually accidentally try to change some value, and by making it const, it prevents you from doing a dumb mistake. We'll do a lot of defensive programming in this class.
So you only want to use const when you know you're not going to want to change it. You don't want to change it.
You're asking, do you only want to use const when you know you're not going to change it? I would say 99% of the time that will be the case. We should make const our default option. I'm going to throw const everywhere.
Okay.
Yes?
So if you think about it, the function's taking an address, right? Or
Don't even think that in this one,
yeah.
don't go that far. Don't think that the function's taking the address. Think that the compiler can see this and say, well, I know where some value's coming from, so I'm not even going to turn this into a pointer. I just know where it's at, so I'm going to compile it knowing where it's at.
Okay. I was going to say, because how I understand it is you don't want to change that address accidentally, or you protect yourself.
This doesn't have anything to do with addresses
Oh,
at this point. It compiles out almost as if it wasn't there.
okay.
Does that help?
Yeah.
Yes.
So keeping on the const thing, the issue of having it being like possibly someone else making the function, them changing it, is it better than to make your data type const before you send it through? Because otherwise, if they created the function,
Yeah, we're going to make, the best rule of thumb is make everything you possibly can const by default, even the stuff out here. So if you have a variable, you load it and you're not going to change it, make it const.
okay, just regardless.
Yes, that's my rule of thumb. I mean, I'm being picky. This is the point where if your application, if it doesn't care about speed and it just runs, who cares really? But if you want to be a nerdy, proper programmer and hold your pinky up in the air and act snooty, you should const everything. Yes?
My second question was, is there any benefit to using like a pass by reference over a pointer, or is it just personal preference?
Pass by reference over a pointer. Pass by reference avoids a dereference hop. When you have an address to something, in order to get to its data, you have to dereference the pointer, which means you have an address, you have to go all the way out to RAM to that address and then go retrieve the data. The compile program doesn't know better. When you just have the true reference to it, you don't have to make that additional hop to go to an address. You just have the data.
So is there any case you want to use the pointer over the reference?
Older code you're interfacing with, the reason you would use it is a lot of times you're interfacing with C libraries. And in C libraries, they only accept pointers, so you have to do it that way. But the reference way is usually superior. Other questions? For those of you who are hazy, is there any other part you'd like to cover? You sure? What part, can you define your haziness? That's usually a hard question. What part of all this do you not like?
We pretty much already answered it
I was going to say, I think a lot of us might get a little bit better understanding if we actually had an
You just need
assignment.
more time. You need to let it sink in. It's a lot to throw at you all at once. Sure.
You say, I think the more that we use it, the more it's going to make sense at this point. Because the concepts are all there, but
Yep.
what do we do with them?
All right, so let's go back. Where were we here? I did an extra thing that I didn't mention. We've done dynamic allocation, deallocation. We've done treating arrays and pointers as if they're the same thing. We've done pointer arithmetic. We do need to talk about the address of operator. We did that one. We just also covered pass by value, pass by pointer, pass by reference, and pass by move. So we still have templates. We have unique pointers, shared pointers, raw pointers, and we have templates implementing a container. Let's talk about the unique pointers and shared pointers. Yes?
Sorry, just to make sure. So pass by pointer and pass by reference, they're the exact same.
No, pass by pointer is not the same as pass by reference.
But essentially they do the same thing, right?
No, the compiler treats the two differently. They feel similar, but there's one distinct difference. This is slightly more inefficient because it has to do one additional, go out to memory, get the address, go out again to the address, go get the data. That's an additional hop.
Yeah, 'cause
Whereas
that's-
this one
that's
just
what
has to
I
go
learned
out.
was passed by
This has to
reference
go out to
using
memory
the
twice. This has to go out to memory once.
Okay.
And the syntax is uglier.
Yeah.
Boy, Nayab, you got me thinking about the comments you said earlier. I've had other class where I would do nothing but your mama jokes all class period. Like, students were loving it. Your mom was so fat, and they thought it was the best class in the world. I had to rap fat jokes throughout my lectures. And now I'm paranoid about making any sarcastic joke again. Other questions so far? Yes? You had a question? Anybody else? All right, so we were going into the shared pointer and unique pointer. What we saw before was a raw pointer way of doing things. Raw pointers are not, they're prone to user error because you have to manually remember to clean it up and set it to null pointer. It's very easy to make. To write beyond array bounds, it's very easy to forget to reclaim. And often the gains you get of performance are not worth all the effort. Java will automatically clean up its own stuff. .NET does the same. They have automatic garbage collection. C++ doesn't have some kind of automatic garbage collection, but there is something we can do. Let's start with the unique pointer. I think that's the best way to go. I will not do it the raw pointer way anymore. I'm going to do it the unique pointer way. To use the unique pointer, I first have to come up to the top and say include memory. Then I have to say using std unique pointer and using std make unique. You got that so far? Now I'm going to make my array this way. Unique pointer char array is equal to make unique a char array of size 10, was it 10 million or 100 million? 10 million. Is that it? Go away, red squiggly. Oh, I didn't give it a name. ARR. All right, go away, red squiggly. There we go. It's weirder looking syntax because unique pointers are really a defined class. It's its own data type. It's not some true pointer that's part of C++ itself. It's actually a library that wraps a real pointer. And we have to use some templates to make it work. You kind of know some template syntax. You might have seen it before, but not really. So the syntax is weird at first. It might make sense at the end of the semester, but at this point you almost have to memorize the syntax. But do you see how it relates? Instead of new, I say make unique. Here's the data type, char array. Here I'm actually, because I'm making a function call, I actually pass in the size into it. And this is returning a unique pointer object for me. You got that? Yes?
So, brief question about the template. Would it accept char pointer, char asterisk as the data type?
I don't think so. I'd have to look. Do it this way. That's the right way. Stop asking what's all the unspecified behavior. All right. I can now access the data the same way I did before. array square bracket 0 is 45, array of square bracket 1 is 46, and so on. I could verify it. In fact, is it going to let me do this? No, I can't do it the old-fashioned way. I have to do it this way now. I will comment out my delete lines. Oops, sorry, I'm scrolling a lot. I will run it just to make sure it works. Oh, that's the old I forgot to get rid of that. The first index is the dash. That was what the 45 correlated to in ASCII. I did get an error. Oh, stack around, the program stack around the variable val was corrupted. I forgot to clean this guy up. Remember this one? Do you remember that old problem? I wrote past val, and it actually said the program stack around the variable val was corrupted. Yeah, because I shouldn't have done that. Let's clear that out. Let's also let's comment out our my function. We're just doing a lot of toying around here. Let's try again just to make sure it works. The first index is that. I hit enter. Here is the really cool part about unique pointers. Did I have to reclaim it?
No.
So does it ever reclaim?
Yes.
Where? Not the compiler. Well, sort of. When it goes out of scope. Where does it go out of scope? At the scope brace. When it goes out of scope, because this thing is really an object, it will call the destructor. The destructor will say, oh, I've been invoked. I must be done. And it will clean itself up for you.
Okay, and that will apply to any kind of objects.
Anything it wraps, it will clean up. You can also throw scope variable braces willy-nilly throughout your program. Now guess what? Is array viable on line 59? It doesn't exist anymore. So it will actually clean up the variable at this point. It'll clean up the entire array for me right here. Do you like that? You don't have to remember delete anymore. You just let it clean itself up. And it will, because it will have to go out of scope eventually. There's no way it can't go out of scope. Unless you make it a global pointer to a unique point. Don't do that. Well, yeah, avoid global variables for a lot of my class.
Well, I've never used them. It's just that, right?
So the question often is brought to me: Why do we use raw pointers if we have unique pointers? What's the downside? Everything in C++ has downsides. For everything good, there's something bad. That's the theme of this class. There is no free lunch. No, the reality is, because one thing is, because it's really an object wrapping something else, often it will incur a performance penalty. The compiler might be smart enough to completely flatten it out, as if all of these calls said, no, really all this is just trying to get the data, so it doesn't do all those calls at runtime, it just gets the data. So you might have a performance problem. Another problem is debugging is not as fun because you have to go within an object to see your data. So it's not so clean. We have to talk about debugging soon. The other interesting part, here's why it's called unique pointer. Only one thing can point to it at a time. You know what you can do with regular raw pointers? Anything you want. If you're a libertarian and you don't want the government telling you how to do anything, then raw pointers are the way to go. It feels the same. Don't tell me what I'm doing. I want to do this myself. I could do this. Char, array 2 is equal to array this way. Can I have two pointers pointing to the same spot? Sure, why not? Would this be a good idea?
Oh, I guess not.
This is called a double free. Is that good?
No.
Why?
I'm going to assume it leads to undefined behavior.
It leads to undefined behavior. You shouldn't do it. Usually it crashes. Can I reclaim the same area of memory twice? They have the same address. Does the compiler know that they're the same address? No. So you can have these problems where you have two pointers pointing to the same thing. Can I do this with unique pointers? Let's try it. Unique pointer, char, square brackets, ARR2 is equal to ARR. Guess what? Not only is it not allowed, it enforces it at the compiler level. It won't even compile. Unique pointer is so named because only one thing can point to it at once. I often think of unique pointers as being like you walking a dog. Suppose, oh, why won't it draw again? Maybe I'll just, let's unplug and plug back in. It was doing this to me earlier too. Oh, pens can die, can't they? Do they have batteries in it? Or do they just have magnets in? I don't know. Try once more. No, it shouldn't because it can see where I am, right?
Oh, that's true.
We should probably pause the video while I play with my pen. Oh, click. All right, no more drawing for me today. That makes me sad. I'll do my best to describe it. I could try it with ASCII art. Let's see, how do we do this in ASCII art? There's the neck. No, because online students need to see this.
Can't they see it?
Yeah, the whiteboard's right
Your
there.
camera?
I dropped my laptop, so my camera doesn't always work.
Oh.
So let's say that I've got a dog on a leash. Here's the leash. I don't even want to try to draw. Here's the dog. It's just it's two eyeballs. This is terrible. The idea of it is the unique pointer would be the leash. You are the programmer, the dog is the object. Does it make sense to have two leashes holding the same dog? That's a silly concept, but raw pointers allow it, but this unique pointer approach doesn't allow it. Well, how do I hand the unique pointer to other things to work with? Was I able to hand it off to make a copy of it? No, it doesn't allow it. It won't compile. There's two ways around it. One is moving. We don't know about moving yet. We shouldn't know about it for weeks to come. The other way is that you just don't do this. And if you ever try to pass it into a function, you pass it in by reference. That's okay because by reference isn't making a copy of it. No. Do you want to have should you do a raw pointer to a unique pointer? Please no. Just do by reference and you're going to be okay. All right. There's another one called shared pointer. Take a wild guess what shared pointer does. It has an actual count. So you can have multiple things. This is going back to having multiple people holding multiple leashes on the same dog. Sometimes you do need multiple pointers to the same item. Also, it has a count inside of it. How many people are pointing to it? Every time a shared pointer object goes out of scope, it decrements the counter. When the counter hits 0, it cleans it up for you automatically. The problem with shared pointer, there isn't a make shared yet. It's coming in C++ 20.
Oh.
There is another longer syntax way to do it, which I think is new char. I think you have to do it this way. I forget. Oh, you'd have to first, number one, say using std make, or shared pointer. I forgot that. Using std. There is a make shared. It just doesn't work for arrays. So you do have a make shared, but I'd have to look it up. There's some syntax that you can get a shared pointer to an array. But for now, we'll be using unique pointers. Does that help give you an overview of the 3 different pointer types? There will be a 4th kind of pointer type called iterators that we'll be dealing with a few weeks from now. They're kind of called smart pointers. We will deal with iterators another day, but for now we know we have raw pointers, shared pointers, unique pointers. Let me ask you this. What would you prefer from here on out? Would you like to go the true raw way and do raw pointers? It helps you be better programmers, but it also beats you up more. Or would you like to go the unique pointer way? It's a little harder to debug, but it takes care of, it's cleaner, and it makes programming easier. Let's do it by vote. Choose your fate. How many of you would like raw pointers? Oh, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many of you want unique pointers? Wow. Raw pointers have won this vote. This is very unique for me. In previous semesters, this hasn't happened. All right. Let's start by showing the next part of the lecture, which will be templates and a container which internally holds an array. I want to demonstrate something I call a safe array. A safe array wraps an actual array. It acts like an array, but it prevents you from going outside of bounds. So that's my whole goal here, and it will help me demonstrate a lot of these concepts. Also, let's go ahead and do the next participation digit. What should be the second participation digit? 3 is our second participation digit. What was the first participation digit? You'll have to go back in the lecture video and find out.
Sorry, we kind of...
Don't say it. No. Online students, did you get the second participation digit? Uh-oh. Yes, we're good. I feel like using that Mickey Mouse Club. Shh, this is a secret which we'll use later. Haven't seen that meme? This is a secret code. It will come handy later on. All right. I'm going to clear out all this. Is that all right for me to clear this out? You've got the video of it. I'm not posting this code. It's just, it doesn't really make sense to post this. Yes?
Is there something wrong with the make shared pointer?
You can't use make shared. I don't know how to do this. I'd have to look it up. Make shared for arrays requires a new inside.
Okay.
Just know that if you ever do want to make shared of an array, you have to go through additional syntax to get there.
Okay.
In C++20, it'll work.
Okay.
But we're on 17, and I think our compilers are only for 14. All right, I'm going to clear all this out. Let's clear all this out. And you guys said, you voted strongly to no longer use the shared pointer and the unique pointer. Let's get rid of all those. Yes?
I want to know why the majority chose.
Because they're better than you.
Savage.
Like, we have one spokesperson.
What was that?
Like,
I
we
would.
have,
I think we just want to become familiar with the...
I mean, if you want to be programming in other like lower level languages than C++, you're gonna need it everywhere.
I'll try to mix them through the semester. I like to do some raw, but I want to move to unique pointers soon too. I can tell you the industry standard now is use shared pointers or unique pointers as often as possible, and only use raw pointers when speed is the factor, is a very vital factor, or you're interfacing with a library that doesn't accept it. But I think raw pointers are great for us to understand computer architecture, good practice, good for debugging. It helps you to understand the later architecture class, or if you haven't taken that yet. Are you upset, though, about using raw pointer?
I'm not
All right.
Because in assignments,
You're not snooty about
in
it.
assignments we can use whatever pointer we want, right?
What was that?
In assignments we can use whatever. Type
No, I will tell you that I only want you to, since we chose raw, we're going to do raw for our first assignment.
Gosh.
Oh,
Do we have
alright.
some shade?
Do we want to do you want wait, do you want to re-vote now on
So
this?
I guess that would make sense if the assignment was like specifically about...
Well, because here's the problem: is the first assignment I have to handhold you a lot for good reason. A lot of you forgot this; you need help, and so whatever lecture I give will be analogous to the homework assignment. So if I do this in raw pointers, the homework assignment should be raw pointers. Keeps it clean across the board.
The
Yes.
first assignment is about stacks, right? And queues.
Likely. Why?
Well,
Because you're looking at this.
syllabus.
Oh, yeah. And also you have the file name right up there too.
Yeah, that too.
Oh,
but
okay.
will raw pointers work with that well? Or?
Yeah, they work just fine.
Okay.
You act like, did nobody have the ability to do stacks and queues in 2010 before they were introduced? Yeah, I mean, raw pointers have been around for forever.
Yeah, that makes sense.
All right, so let's keep going here. Let's make a class called Safe Array. And I'm going to have a public section, a private section, and we want it to wrap an array. For now, I'll assume that it's holding on to integer, or int data. So I will have it an int array. I'll call it int ARR. C++ 11 allows you to initialize variables now. You couldn't do that in older C++ versions. I like auto initialization because, in my opinion, pointers should never, when you declare a pointer, what does it default the value to if you don't initialize it to anything in particular?
I really thought.
Well, here's a good question. Let's go simpler. Int val. Cout val. What is it? What will it show you?
Has not been initialized.
No, what will it display? It could compile.
Oh, it's usually just some random.
Whatever garbage was in memory at the time. C++ does not auto-initialize variables for you. It's dumpster diving. For speed reasons. And auto-initialization it costs speed. Here's a good motto of C++ is retains all the possible performance. I should say does its best job to retain all the possible performance of machine code, but abstracted into easily readable programmer code. Have any of you coded in assembly yet? Some of you have, most of you haven't. It's very low level. You are right at the machine level itself. You are giving the exact instructions to the compiler. Because you have the exact instructions, there's no abstractions between you and the CPU. I said compiler in there, I didn't mean to. I meant CPU. You have direct access to the CPU. You can tell it exactly what you want it to do. Because of that, you have full control over its performance. When you use a language like C++, .NET, Java, you don't have direct access to how it compiles. C++'s job is to say, let's make sure that we never sacrifice performance at all possible. We want this, that if a programmer says, I want this code to act as it's the same speed as hand-rolled assembly, you should be able to do it with C++. Does that make sense?
Yeah.
So that's why you have some of the weird anomalies and idiosyncrasies of the syntax. It feels a bit weird because it's trying to preserve performance if you would like the performance. Languages like Java, C#, Python, is performance their number one priority? No, what's the number one priority of Java?
Usability. Well,
Run it everywhere. We run on 3 billion devices. Yeah, I know. You tell me that every time I install. What's .NET's main feature? What's its selling point? We're not Java, and it's easy to use, and this is a great business language. We work great with databases. We work great with servers. You want to get just most common applications done, use C#. How about Python? I don't even like programming at all. I'm a mathematician. Give me an easy language, please. Python's horrid for performance, but it sure looks pretty. Do you like it? It's pretty, isn't it? And it gets mad like, you didn't use your proper amount of spaces. I won't compile. Don't give me semicolons. That's for the nerds.
That's for the It's going to be like confusing coding in Python at work and then like in C++ is.
So C++ is all about retaining the performance. And so if I declare a plain old pointer, what address is in array at this point on line 19? Some random address. Is that a good thing to have random addresses to spots in memory? Usually it's not. So a good idea is to say never let yourself have a garbage address. So you have this weird initialization syntax. This doesn't mean run code, run the code null pointer, stop running code. No, the curly braces here mean initialize. Curly braces has been reused to mean something else. Just as curly braces here means definition, curly braces here means scope of program. Different uses for curly brace. You got it? All right, so we've got array. I should also keep track of how big the array is. There's something better than int to keep track of it. I will call it unsigned int. Why will I do unsigned int? What does unsigned int mean? Can't be negative. If you take computer architecture, you'll understand that a signed int means it could treat it as if it's negative. And so a bit is used to tell if it's part of it's negative or not. I don't care. I want it to always be 0 or above. Let's call it capacity. Let's initialize capacity to 0 because initialization is a good thing. You got that so far?
Your bracket is the same thing as just putting equals.
No, it's not the same thing as putting equals because equals is a second step. First it creates it with garbage, then in a second step it copies the 0 into it. That's a two-step process. Believe it or not, the equals is an oversight. Programmers are really mad that they left that in. They wish they did it all this way and banned the equals assignment for initialization.
So this initialization syntax here, this is going to work outside of declaring class members, right?
Yeah, when I declare a safe array object down below, it will auto-initialize those two.
Well, yeah. Just if I wanted to use this initialization syntax for just some int somewhere in a function, another scope.
Yeah, it works everywhere. I could do it like that. That's actually slightly more efficient than this way, but most compilers will see what you're doing, and where I said this is less efficient, for integers, most compilers will treat them the same. But for more complicated stuff like collections of collections, this is better, this is a problem. Compilers can't compile out all things. Hey, let's get that third participation digit. What should be the third participation digit?
7.
7 it is. The third participation digit is a 7. Second participation digit was shown earlier. You got the third participation digit? I can highlight it on screen. All right. Let's start, I'm going to start acting like I can use safe array in main. If you ever have a problem in your head designing a class, instead of trying to design the whole class first, instead act like the class has already been designed and you can use it in main. That will help tell you how to design it. So suppose I have a safe array object. I'll call it my safe. I'll just call it my object. And I want to initialize it to hold 10 values. Then I'd like to be able to do the following. Let's do a for loop and initialize all the values of this thing to my object dot. Do you want to use square brackets or just a method call? I could do it this way. Item I is equal to the value I times I. I'm loading squares in here. Or I could do it this way. Which of these two do you like better?
Let's do brackets.
Brackets look easier.
Well, they look harder to implement. But nice.
Here's the rule of thumb. If it's easier for the user, it's harder for you to implement. Let's do both. And then we'll do this for int I equals 0, I is less than 10, I plus plus. I want to say my object, or let's just do a cout, my object I. Let's do a .get I for now. Does that seem straightforward how I want to use this thing? Just to get it started. All right. Let's start at line 17. What does that line imply must happen up in my class?
It's gotta be constructor.
This is constructor syntax. It needs a constructor, and how many arguments am I passing into the constructor? One. What is the data type of what I'm passing into the constructor? Be more specific than int. Unsigned int. Could we do even better? Const unsigned int. Could we do better than that? By reference, const unsigned int. Let's do it. Safe array will be my constructor. I will have a const unsigned int by reference capacity. I will also be a snooty proper C++ programmer and not an unwashed Java programmer. I will not define my constructor in the class. This is the declaration. The definition goes below. So inside the safe array, there is a member called safe array who has this parameter type. So now I'm defining the constructor here. Yes?
So the purpose of a constructor is to initialize all the data members, right?
Yes. In this situation, well, some of them, my data members can be initialized automatically, but if the user has to initialize them, or I have dynamic memory, I would want to use the constructor to do it for me. Does that make sense?
Yeah.
All right. So let's start. How do I get the array to be loaded to have 10 values from the heap? What line of code do I type? This array right now is just pointing to null pointer. I have not allocated any memory on the heap yet. I have to use the heap because this is dynamic. I don't know what the user wants. The user wants 10. I know that at runtime. So I have to use the new keyword. Correct? Because we're doing raw pointers. Raw pointers use the new keyword. Good. So we know there's going to be a new in here somewhere. Now what? What type of pointer? Tell me what I type. My fingers are itching to hit the keyboard. Int pointer. I should ask all my questions as if it's a question to throw everybody off.
Looks like someone wrote it in the comments there.
Trevor says, this ARR is equal to new int capacity. That's correct. Common mistakes. As Adam was saying, you wanted to put an int pointer here. That's not correct because that will make an array of pointers. We don't need an array of pointers, I just need an array of ints. You got that?
Yeah.
The second very common mistake is that a lot of you will do this. This is really, really, really bad. Right now I'm raising a 2-year-old. My way to teach him things that I don't want him to get hurt is to say like, hey, this is the fireplace. This will burn your fingers. This will really hurt. Here, give me your hand. Let's go touch the fireplace. We're going to go to the hospital. It will make you cry. For those of you like are not parents, oh my gosh, I'm going to call the government. For those of you who are parents, like, yeah, that works. Why? Because what's his first reaction? No, I don't want this. It's going to hurt. No, we're going to touch the fireplace. No. Now is he ever going to touch the fireplace? No, I'm a good dad.
Great job.
I wish I could do this to you. Okay, everybody, we're going to do this. This is a great idea. And then I can make you, and then I can smack you really hard. Why is this bad?
Well, it's at least not going.
There's one really bad thing that happens here.
It overwrites the other.
Is that ARR the same as this ARR? No, this is a second ARR. It's a local variable that is not the data member. So the local variable has the ARR, then what happens? It goes out of scope. So we get the address and then we promptly lose it. Meanwhile, do we ever have the regular ARR? Do you see the problem? That's really bad. The way we fix it, if you ever say this arrow is always referring to the data member. It's an objects member. You can't mess it up that way. So now I'm saying, and in fact, the auto highlighted it for me. See how they're both gray? This ARR is referring to this ARR up here. Now when the constructor is over, your correct ARR, the only ARR, still has the address. All right, I'm at 9:11. I've gone over time. You should complain about me. Let's do 3 more participation digits. Yell out some digits for me. 4, 2. That's a good.
4 again.
4 again. We have 3 more participation digits. The other 3 were earlier in the lecture video. I will have a participation quiz open at the start, or in the Canvas class. I do not have enough time to get you the first assignment this weekend. So we will get the first assignment out on Tuesday next week. You good with that? I know some of you asked, well, can you give me the assignment early so I can jump ahead? No, we'll just wait. I want people who are behind to feel like they have the same amount of time to get it done. We have a lot more to cover. We got to talk about templates, using more of these classes, operator overloading, what a stack and a queue is before I can get you the first assignment. All right, any other questions for me? So Nayab, I think I understand why. They may have been in one of these classes of mine. I used to have classes where I would have something really important, act like there's something really important, and then I'd cut the lecture video off. Just to mess with people. So maybe they were in one of those classes. That said, Weaver State has a new program where if you do a 2-hour information gathering session up at the Ogden campus, you get 10% of your tuition back. All you need to know is you just need to